Hi friends, welcome to GMK tutorial. In this video, we are going to deal about the electronic devices and circuits basics also. Let us say in our previous also we discussed regarding the PN junction type material also. So just we will recap the topics very quickly. Okay, ఇప్పటివరకు ఎవరైనా ఛానల్ ఇంకా సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్. Okay, fine. So let us see generally semiconductors. Semiconductor means that the characteristics of the material lies between insulator and conductor. That is generally called as a semiconductor. Suppose let us see, this is a conductor, this is a insulator. In between it acts as a semiconductors properties. Here the properties of the semiconductor is lies between the conductor as well as insulator. Conductors allows the current, insulator allows the it does not allows the current. So it acts as the insulator means it does not allow the any current. Conductor allows the current. So generally we have a two types of semiconductor materials. Semiconductors are fourth group elements like silicon, germanium. These two are mostly used materials. Okay, now let us define what is meant by PN junction. Silicon is mostly used material compared to germanium. Silicon is mostly used material compared to germanium because the characteristics of the silicon is does not change with respect to temperature. It is not that much of a sensitive to the temperature, but germanium is very sensitive to the temperature. Therefore, silicon is preferred widely. Okay, so let us define what is meant by PN junction. So PN junction is sandwich of P type and N type material. The semiconductor is sandwich of P type and N type semiconductor material forms a PN junction. Forms PN junction, right? So back to PN junction means that like this. If we are taking P is a material, this is nothing but this is a anode, this is nothing but a cathode. Okay, so this is nothing positive terminal, this is nothing but a negative terminal. The symbolic representation of the PN junction diode is like this. So anode, cathode, as well as the characteristics already studied in the previous video. So let us define what is. So if you are observing this one, the characteristics is okay, this is for germanium, this is for silicon. Okay, there is the current, this is a forward voltage, this is a forward current, right? So it start around 0.28 around, it is 0.45, but ideal value is 0.7, 0.3. These are ideal values. So now let us define the transistor. What is meant by transistor? Let us define let us define transistor. Transistor means that a back-to-back connection of back-to-back connection of two PN junction diodes. Back-to-back connection of two PN junction diodes is generally called as a transistor, or else a transfer of resistance from low resistance region to high resistance region. This is also, we can define it like this. A transistor is nothing but a back-to-back connection of two PN junction diodes, or else a transfer of resistance from low resistance region to high resistance region. It is also called as a transistor, right? Then let us see how it is there. So this is the generally PN junction diode. So the back-to-back, it is the back side of the PN junction diode. Suppose if you are connecting these two in a back-to-back manner, it forms as a like this. So this is nothing but a back-to-back connection of a PN junction. So this is nothing but a positive terminal. This is nothing but N. This is nothing but N. So this is generally called as a PNP transistor. If you are connecting in this another backside direction, this is nothing but NPN. This is nothing but NPN transistor. Okay. So we have, it forms as a two types of transistor, that is nothing but PNP transistor, and second one is nothing but a NPN transistor. Okay. Now let us see the symbolic representation. Symbolic representation of transistor. Okay, how we are going to represent? This is the symbolic representation of transistor: base, emitter, collector. So this is nothing but a NPN transistor. In case of the NPN transistor, this arrow is outside. This arrow represents the direction of the current. Okay. Then if you go for the PNP transistor, so arrow is towards this direction. Now base, emitter, collector, right? Then you can see in the block diagram format. So in case of the transistor, what are the terminals? Terminals of a transistor. Terminals of transistor. What are the terminals? That is nothing but base. Second one is nothing but emitter. Third one is nothing but collector. These are the terminals of a transistor, right? So let us see the some more basics. Base. Base is nothing but it is lightly doped material. It is lightly doped material. Base is a lightly doped material. Let us see what is meant by emitter. Emitter means that which emits the electrons. Emitter is nothing but which emits the electron. It is nothing but heavily doped and heavily, moderately doped. Okay, no? Moderately base is emitter is nothing but heavily doped. Okay, so collector is nothing but moderately doped. Collector is nothing but moderately doped. Moderately doped. If the size of the device's base is a very thin, moderate size, so this is nothing but large size. So this is a very brief introduction about the NPN transistor. Okay, that is nothing what is meant by transistor, how we are going to represent. So generally transistors are of two types, that is nothing but NPN transistor, and second one is nothing but a PNP transistor. So let us see what is meant by NPN transistor. NPN transistor. So let us see the diagram for this one. NPN. This is nothing but emitter, this is nothing but base, this is nothing but a collector. So in case of the NPN transistor, that must be first junction is in forward bias condition. So negative, positive, NPN. So it is in a forward bias condition, plus minus, this is nothing but VBE, base emitter voltage. So second one is nothing but NPN transistor is in a reverse bias condition. Therefore, it is nothing but negative, it is nothing but positive. Therefore, the positive terminal of the battery is connected to the N-type collector, as well as negative terminal is connected to the P-type base. Therefore, it forms as a reverse bias. Therefore, first VCB. Okay. Therefore, the first junction is in forward bias and second junction is in reverse bias. It is in a forward bias. This is nothing but a reverse bias. Okay, the operation is very quite simple. Okay, let us see here. If you are going to analyze this one, when the negative or so when the VB voltage is increases, let us see, just I will give a very quick review. If VBE is increases, electrons in N-type emitter repel and move towards the collector, right? So what happens if when the negative terminal is connected to the N-type semiconductor material? In case of the N-type semiconductor material, the majority charge carriers are electrons and minority charge carriers are holes. Therefore, when the negative terminal is connected to this one, what happens is that the electrons are moving towards the collector side, as well as in case of the this is nothing but a depletion region. In case of the p-type semiconductor, what happens is that in case of the p-type semiconductor, majority charge carriers are holes and minority charge carriers are electrons, right? So when the VB voltage increases, what happens is that the negative electrons crosses the base region and entering into the collector region, right? So here the positive terminal will be there. This positive terminal attracts the electrons in the collector region. Therefore, the current is passing in the direction. The current is conventional current is opposite to the actual current. Okay, current direction is always opposite to the conventional direction. So actually the conventional direction is nothing but positive to negative. Okay. So this is the direction of the current, this is the direction of the electron direction, this is nothing but conventional current direction. So this is a basic operation of the NPN transistor simply, right? So if you want to analyze the PNP transistor, same consideration, just we are connecting the first junction is in a forward bias condition, second junction is in the reverse bias condition. Okay, then only it should be working in a proper manner. Okay. I hope this video is very clear for you up to now, right? Just we can recap all those things very in short time, right? So this is nothing but a NPN transistor. Now if you want to analyze the PNP transistor, that is also very similar way. So let us see the just a block diagram for this one, PNP transistor. Just I don't want to analyze the characteristics of the transistor, just I will give the block diagram analysis for NPN and PNP transistor. Okay, so let us see, this is a PNP transistor, PNP. Okay, so if you want to analyze the corresponding PNP transistor, the first junction must be in the forward bias condition. Therefore, the positive terminal of the battery is connected to the P-type semiconductor. N-type battery is connected to the negative terminal of the base. So this is generally called as an emitter. This is generally called as a base. This is generally called as a collector. Right? So now the second junction is in the reverse bias condition. Therefore, positive, negative. Okay, negative, positive. Now let us see the voltage denotation. So this is nothing but VBE, voice voltage. This is nothing but VCB. Right? This is the just a block diagrammatic representation for the PNP transistor. Now just you have to analyze the analysis of the NPN transistor. Let us see very clearly. So in case of the P-type semiconductor, just I will mention, in case of the P-type semiconductor, majority charge carriers are holes, minority charge carriers are electrons, as well as in case of the N-type, majority are electrons, minority are holes. This is very important, right? If you know this basic only, then this analysis is very quite easy, right? So let us see here, this is a block diagrammatic representation. Now what happens is that, first point, if VBE is increases, the holes in the P-type semiconductor, that means the holes are the majority. I will denote holes as like this. Okay, electrons can be represented minus and holes can be represented as, so the holes in the majority holes are the majority charge carriers in case of the P-type semiconductor, right? So if the VB is increases, means that the holes in the P-type semiconductor is move towards the base and crosses the base region and enters into collector region. Okay, enters into the collector region. At this time, now these are the electrons are present. Okay, these electrons are in case the electrons present in the collector region are attracted by the negative terminal of the, sorry, so here the holes are moving in this direction, right? Not electrons. So in the VB is increases, holes in the P-type semiconductor is move towards the base and crosses the base region and entering into the collector region. Now what happens is that in case of the, so now holes are the majority charge carriers in case of the collector region also. These holes are the holes present in the, so one more point is nothing but the holes present in the, second point, the holes present in the P-type collector attracted by the negative terminal of the battery. So the current starts conduction. The current starts under conduction of the current. So the current starts flowing from emitter to current starts from emitter to collector. Okay, so this is the way we are going to analyze the PNP as well as NPN transistor very quickly. If you know this basic thing, just you can analyze each and everything in the transistor. Generally, in case of the transistor, we have a three types of regions are there. Okay, transistor consisting of a three types of regions in transistor. What are the regions? We have a three types of a transistors or the regions are there. That is nothing but cutoff region, cutoff. Second one is nothing but active region, and third one is nothing but saturation. Okay, cutoff region means that both junctions reverse bias, J1 forward bias. If you are taking first junction is can be treated as a J1, that is nothing but forward bias. Junction 2 J2 is in reverse bias. In case of the saturation, J1 is in forward bias. Both the junctions in case of the saturation region are in a forward bias condition. That is very important, right? So let us see, this is nothing but a forward bias region, as well as J2 is also is in a forward bias. This is the regions in case of the transistor. In case of the cutoff region, this transistor act as a half switch. In case of the active region, it acts as a amplifier. So in case of the saturation, it acts as a on switch. So this is a very quick revision of a transistor, how we are going to analyze the transistor. Okay, I hope this video is somewhat clear to you. Okay, if you don't have any basics in the electronics, right? So thank you for watching GMK tutorial. Thanks a lot.